When I'm building this board, I usually like to go from lowest to highest as far as board height. So that would mean start with resistors. And so let's start with our two 180s and the 330, and these are for the RGB LED up here. So you can see here the 180 goes here, another 180, and then our 330 goes right here. And these are different values because the forward voltage of the different colors on the RGB LED are different. The blue is the highest, and so it gets the lower resistor, the 180. So we've also got over here our two 10K resistors, and those are for the I2C lines, pull-up resistors. And so these go in here. Like so. And while we're at it here, let's see, we need one more 330 resistor to go up on the top here, and then while we're at it, let's do our diode up here. This is just a little bit of a kickback diode for the motor transistor. And the diodes have a black band on one side. These do have a polarity, and that black band matches up with the little marking there on that. So that goes like that. Alright, you can see I'm still missing a 330 here. We'll get that in a minute. Alright, let's solder some of these in place here. So I'm not going to make this a how to solder video because that's done elsewhere on the web much better than I can, but I'll just show you in general. Clean tip, I'm using a SparkFun $10 soldering iron that I really like, and I'm using lead-free solder. So I'll go in and I'll touch the lead of the component and the pad at the same time, and then wait about 2 seconds. Introduce some solder, and it should wick right in, and you'll be golden. And then you always got to remember to bring your tip away first, or bring your solder away first and then the tip, otherwise it'll solidify on there and your solder will be stuck. So like I said, I really like this iron. For the price, you can't beat it, and it does do lead-free solder nicely. And so we use it for our workshops. Love it. Get the right angle on this. And as you can see on the back of this board, I've got all the silk screening showing which pins go where, in case you don't have the library installed or the documentation. I kind of like my shields to be kind of self-documenting. So once you get your solder in place and you're happy with it, then you clip them off as close as you can. This is where you kind of want to keep a thumb on one end of the lead, because they'll go flying off. We always have kids wear safety glasses at our workshop when they're soldering, just primarily because these things go flying everywhere, and certainly wouldn't want hot solder to get in anybody's eye either. Okay, so still need a 330, and also want to get, so now we've got everything in. So now the LEDs for the resistors for the LEDs, and these can be different values depending on which LEDs you put in. So if you're putting in like blue or green, you're going to need different values than if you're doing just red and yellow. Red and yellow are pretty standard, and we're using a 330 ohm resistors. Let's see, so we're still missing one resistor here, but I think I'm gonna go a bit further now. So we've got these I2C headers on here on the right, and it's kind of arbitrary which side is which, especially if you only have one board. It doesn't really matter. This is actually designed for hooking two boards together or hooking a Wii nunchuck in. I usually put the male one on the bottom so you can kind of see the silk screening there, and you want to get these on at this point because once you get the any more components on the board, it's going to get harder to get that on right. Okay, with the header I usually just solder one on and then check the alignment. Looks okay, and then we can solder the rest on. This particular shield is going to the Netherlands. I seem to have a disproportionate number of people buying my kits from the Netherlands. So if you happen to know why the Netherlands is so tech savvy, let me know. Okay, and next, as far as heights would be this shift register here. Shift register IC chip usually has a notch denoting where pin number 1 is, and a notch on the silk screening. And it comes with some anti-static foam, and I may or may not have already bent these so they're straight, and it's just a matter of getting those into the right sockets. And of course it never goes quite like you'd hoped. Alright, there we're heading. Okay, so pin 1, pin 1. Let's go ahead and solder some in place here. Anything with multiple pins in it, I'll usually solder in just kind of 2 of the pins, in this case the opposite corners, and then come back over and make sure that the package is sitting flat on the board, and then double check your alignment, because once you solder in more than 2 pins, it's going to get exponentially harder to unsolder if you actually do get it in backwards. And trust me, I've gotten my fair share in backwards. in our temperature IC, which is a TMP36, and the NPN. So I like putting these in the same time because if you get one in right, the other one will be right. So you look closely at the silk screen. This one will say TMP36 on there somewhere. And then this one usually comes taped, and it'll be a 2N4441. I'm sorry, 4401. That's a pretty standard NPN transistor. So these have polarity, and they've got to go in the right spot, otherwise it won't work. So on your silk screen, you have temperature, and then you have your NPN transistor with the silk screen showing the emitter, base, and collector. In case you have any questions about that, you can look at your data sheet in case you're using a different kind of transistor. Sometimes the packages have different pinouts. So temperature sensor, going where temperature's at. And you can pull the tape off, or you can just clip it. And the flat side goes to the flat side, like so. And let's solder this in place. And again, you know, I'm just going to do one pin and then come around and double check. Make sure they're seated the way I want them and that I got the right one in the right place. I think the extra time it takes to double check your work more than pays off, and the time and frustration it takes to have to unsolder one of these and solder it back in. Okay, and let's clip these down where you can see it. See this little Made in Oregon symbol on here. I actually have these circuit boards made up in Lake Oswego by OSH Park. I've really been happy with their service. They do small and medium batch runs. Makes it easy to get a prototype out quick or to build enough for a hobbyist to do a kit. Okay, so let's put in our buttons. We'll start with these. These are 12 by 12, and you can see on the silk screen there's actually a smaller pad in here, so you could put the, if you just had smaller buttons, they would fit on there and function as well. With the kits, this is the reset button. It goes right here in the middle, and then these two are the tactiles. And I've seen some sold with like colored covers that are kind of cool. And let's see, and let's do our piezo speaker too. Well, I've got the board over here. So there's two footprints for the speaker as well. SparkFun sells one that has a polarity and a wider footprint, and so that would be the horizontal alignment with the positive there. I like these PS1201 speakers, like Adafruit sells. It has no polarity and a shorter footprint, and so that will go in vertical orientation like that. And then we're ready for that. Ready. So like I said, I forgot to do the photo cell up here. I've started some of my kits using a photo transistor or photodiode, and they're a little less expensive, and they're also operate much quicker as far as, they're about order of magnitude quicker as far as response levels. But this one's got a regular photo resistor in it. And so so now I think, as far as height wise, you see we're down there, so now I think it's time for our LEDs. Are gonna fit right in there, and it's kind of up to you how you put them, depending on what you bought or what you've got. I kind of like doing red on the left and yellow on the other side. LEDs have a polarity. The long lead is the positive, and on the silk screen there's a positive on the top side, so yellow is going to go. For load these all up. Packages also do sometimes have a flat spot on one side, but I have trouble actually seeing that a lot of times, so I just go by the long LED. So let's go ahead and put in our potentiometer. This will work put in either way, but if you want it to be like a volume switch where this is low and this is high, then you want to put it with the ridges towards the bottom of the board, like so. And I've also, this package is done, so there's a pin out here. If you have one of the potentiometers with an offset, you can fit that in there as well, but this one just goes in right like so. And I got a little solder on there. Oops, and I forgot to check the seating on this, so let's hope we got it in good. Yeah, looks like we did. Clip those down. There's that solder bridge right there. Okay. Now, looking through my notes here to make sure I'm doing it sort of the order that I did it on the Instructable. So up in this row here we have two male headers for the motor and the analog, and then we have a 3-pin header for the servo. And what I like to do on this is just use the header to hold these in place for me while I solder them in. And they're offset by 0.1 inch, so that works like so. Let's hold them pretty nice. And I'll just do one of each here. I got the feeling that I'm a little off on this. And yeah, you can see, so I'm gonna go ahead and gently slide that off. So here's kind of an, where the I'm not sure if the camera's showing that, but they're tilted. So I'm just going to put some pressure with my thumb and heat up the only solder contact on there, and then as the solder liquefies, we should be able to push it flat and get it get it the way we want it. I want it to be nice and straight. Pretty close. Okay, we'll nail these in. It's much easier to align it when it's just one solder joint holding it in place. Don't have to worry about heating multiple joints at once. It's hard. Okay, and then that leaves that 3-pin header there, and so I got my row. I can't remember if these are 36 or 40, but we're just going to clip off 3 there. Go in here, and this is a little tricky because it's the same height as that, so I'm thinking I'm going to use my little foam piece here to hold that in place while I tack one of those on. Sometimes you got to be a little creative. You don't have a lot of extra hands. And then come back and look, and that actually seated pretty nice. So it's straight and flat, so let's nail the rest of these in here. Okay, and with the exception of that 330 ohm resistor that I missed, we'll get back to him. I've left probably the hardest component for last. This is our RGB LED, and it has one leg that is longer than the rest, and that is the ground. And so if we look at our circuitry here, there's one with a box around it that's common cathode or the ground, and then we've got red, green, blue. So if we get this common cathode in right, then the rest is good. So it's that one right there. And then I think the reason they have these different lengths is so that you can get one fitted in and then wiggle it in a little bit. And there we got the blue and the red. And then we'll bring it green and the red, and then there we go. So that's not too bad, and you can see it fits kind of tight with the temperature here, so we'll bend that a little bit out of the way. There are some tangs on the leads here we got to work our way past. I've just never seen a good footprint package for this that I like that was actually solderable. This one kind of spreads them apart so that you can get to them easier, but that means it doesn't sit quite flush. So we're shooting for about 1/8 of an inch here, and that makes those offset like that, so we can get them. And if you notice closely on the bottom here, I have some pads laid out so that if you actually have a common anode, RGB, you can cut the trace on the common cathode side and do a solder blob across the common anode side and use that, because sometimes those are the only RGBs you can find, and different vendors have different ones they like, and it can get confusing. So I like common cathode because it works more the way I think of LEDs working. Common anode, you have to, everything is high, and then you have to pull low to get the light to go. It's kind of strange. Okay. So our next step is to get our headers in place, and standard Arduino Shield has 2 6-pin headers, 2 8-pin headers. So we just got to count these off: 2, 4, 6, 2, 4, 6. I do get these wrong on occasion. 2, 4, 6, 8. So you can sometimes just hold them up like that if you get one right. If you have trouble counting to 8 like I do, 2, 4, 6, 8. Oops, lost count. There's 2, 4. I'm not sure I did that right. Okay, so we used 3 earlier, and that leaves us with 5. Okay, I've got me that errant 330 ohm resistor. A little tricky now that it's so deep in there, but if we bend the leads out right. Okay. Alright, so now I believe we've got all our components installed. If not, we're going to find out soon. Alright, time for my trusty demi-love here. I can't even pronounce it. So I use it as a kind of a jig for getting these headers in correctly. So the short headers are up going into the shield, and then we will just drop our shield right on top there, so that'll hold everything nice and straight for us. Make life easy. We've got it. So final inspection. Let's come around looking for any solder blobs, any bridges. A couple of these pads are open because there were things we didn't use, like the smaller switches. And if you're happy with all that, I think we're good to go. Go back on the demi-love here, and I've loaded a sketch that I wrote just for checking these things out. So we'll fire it up, see what happens. Okay, so the RGB LED, I see a red, I see a green, I see a blue, so that's good. All the 8 LEDs are lighting up, it's going in order, and the intensities look good. The time lapse on these is triggered by the potentiometer, so you can see it slowing down, and so we know our potentiometer is working. This is also going out to the serial monitor, so you can actually read the values and make sure they're acceptable. Press the right button, we'll get tone. Press the left button, we'll get another tone, so we know the speaker's working, the button's working. The only thing we got to check the serial monitor to see if the LED's working. Or, I'm sorry, the photo cell's working. So that's it. I hope you see it is quite a build, but fairly straightforward. And now it's ready for you to program something cool into it. All right, thanks for watching.